All right, so today we're going to do some trigonometry. So the word trigonometry, do you guys know base, like stems of words? Tri means what? Three. Gone? Oh, I know. Leave. Oh, man, that's true. But gone means like a polygon, right? A shape. So it's a three-sided figure. And what about metry? Metry means measure, right? So it's the measurement of three-sided figures. So that's what it means. So it's derived from the Greek language, and it means the measurement of, what do we call three-sided figures? Triangles. So that's what it means. Okay, so we're going to use these ratios, and you're going to use them in geometry, algebra 2, pre-calc, calc, for the rest of time. All right, they're actually quite useful. Colin, put your phone over there. So I had a friend that was building a deck the other day, and he was like, I actually use sine, cosine, and tangent. And the thing that killed me was he was actually a math teacher, and he said, and then I realized that I made the wrong measurement and messed one of them up, and then he cut all the things wrong. So this is why we should measure correctly. We should learn how to do math correctly. So, all right, so if we have ABC as a right triangle, the sine, cosine, and tangent are ratios. They're fractions. All right, sine ends up being the opposite over the hypotenuse. Now, when I say opposite, I mean opposite whatever angle we're talking about. So if I'm talking about angle A, what side is opposite angle A? So what's going to be across from it? BC. Do we want to write out BC, CA, AB, and all that all the time? No. So we develop a way to shortcut this. So the side that's across from angle A, we shortcut it by writing little a. The side that's across from angle B, we shortcut by writing little b, and the side that's across from angle C is little c. You've seen that before with the Pythagorean theorem, a squared plus b squared equals c squared, where c is the hypotenuse. So the side that is opposite angle A is little a, and the hypotenuse is c. So it ends up being a ratio. It's a fraction in the end. Okay? Cosine ends up being adjacent over hypotenuse. So our adjacent, what's next to A? So this is where I always have students that are like, there's two things that are next to A. This is Cox B and C. Right, which one do you think is going to be the adjacent? Yeah.
B.
B, exactly, because I already have a name for the hypotenuse, right? It's C. And then tangent. So tangent is going to be opposite over adjacent, which ends up being A over B. Tangent also works out if you guys go on to take like algebra 2 or pre-calc, which you will, I'm sure. It ends up being like sine over cosine, right? All right, so just remember the word Sohcahtoa. Have you guys seen the word Sohcahtoa before? It's a really weird word. So it means sine of the angle. So sometimes when I write angle, I do a theta. Do you guys know the Greek letter theta? Kind of like pi, it's a Greek letter. So sine is equal to opposite over hypotenuse.
Who found pi?
No one found it. It's always been a letter.
No, I mean like, but who like?
Who was the mathematician? William. No, it wasn't Archimedes. Archimedes did find an approximation for pi, but I gotta look that up. I can't remember. William Jones? Is that right? Did I just pull up? I think Euler, yeah, Euler used it, but Euler's the one that came up with E. There's another number that's E. All right, so cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right, there was a long story about Sohcahtoa when I was growing up, which is probably not politically correct now, so I won't tell it, but Sohcahtoa, so that's how we remember it, is the letters SOH, do you guys see it? Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals adjacent over, or opposite over adjacent. Okay, do you guys see all those letters? If you can spell this word, you will be golden. You'll be able to do this. Can you all spell that word?
Whoa.
All right. Everybody say it. We're going to say it 3 times. Ready? 1, 2, 3. Sohcahtoa. 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 Right? Not Sohcahtoa. Because then you'll forget your H each time, right? Sohcahtoa. All right. So first of all, we're going to make sure that our calculators are in the correct mode. Yeah. Do you have?
I have a really good way of memorizing things.
You do?
Yeah, so can I write on the board?
You can write it on the board, yeah.
Yeah, this is using English, so everyone can memorize.
Okay, I thought you were going to give us some Japanese word for Sohcahtoa.
No, like, so for sine is right cursive of S, so opposite over I don't know, hypotenuse.
Yep. So he's saying.
And then cosine is C, and then opposite over.
Okay, so he's saying that it's an S for sine and it's a C for cosine.
And
You guys see adjacent and hypotenuse.
Tangent is this. So cursive. So.
Oh, okay. So tangent is opposite over adjacent. Oh, I didn't get the opposite over adjacent. But I see what you're saying. So he says that he learned it in cursive S, cursive C, cursive T. All right, so you can know it that way as well. Either way. All right, so get your calculators out. We need to make sure that your calculator is in the correct mode before we can do any of these problems. So if your calculator's in the wrong mode and you guys take a test on trigonometry, it could be terrible. Right? We want to make sure we have the right mode. So there's something that we learn later that's called radian mode. We're not going to use radian mode today. We're using degree mode, right? Because it says sine of 56 degrees. So I want you to hit mode. And when you hit mode, there's a bunch of options. So if you hit mode and you go down, do you guys see how it says radian and degree? You want to make sure that the degree is highlighted. So you're going to go down, and you're going to go over to degree and hit enter. All right, then you want to get out of there. So do you guys see the word quit on your calculator? So it's second, and then if you hit mode again, it has quit above it. So second quit. So we're out of it. We're on our main screen. Okay? So if I want sine of 56, it's very easy. I just put sine, and then I hit 56 and enter. So I should get 0.8290. All right, some of you guys might have calculators that don't look like this. So the basic scientific calculators, you might have to hit 56 and then hit the sine button. So figure out what works on your calculator right now. Does everybody have that number, 0.8290? We good?
Yes.
All right, find cosine of 84. 0.1045.
It's trigonometry.
Not yet. Well, I guess it is, technically. It is trigonometry, yes. All right, and then tangent of 16. Obviously, there's a lot more to the class trigonometry than just typing in tangent 16 on your calculator. But we're doing a little preview in geometry. So we get 0.2867. All right, and that's our answers, okay? So what is that? What that is if I had, you don't have to draw this, but if I have a triangle and I have 56 degrees, it's telling us our value that was the opposite divided by our hypotenuse. And it's telling us when we divide those two numbers out, I'm getting a ratio, a fraction that's around this decimal 0.8290. Does that make sense? Huh?
Could you say that one more time?
So basically, these are trig ratios, meaning the sine of 56 ends up being the opposite side divided by the hypotenuse. Okay, so when I divide these numbers out, opposite divided by hypotenuse, I'm going to get this number, the 0.8290.
What's the ratio?
What's the ratio what?
What does it mean?
It allows us to find measurements of unknowns. So we're going to use it to find like the height of buildings, the height of trees, the things like that. The distance from different places. It's going to be very handy. All right, so find the three trig values for angle A if C is equal to 15, B is equal to 12, and then A we don't know. So how do we find A? Well, we could go back to our A squared plus B squared equals C squared, right? Just make sure your C is your hypotenuse. So we have A squared plus 12 squared. Colin, don't distract her. Equals 15 squared. Poor Caitlin. She's like laughing because she knows it's true. So we get A equals 9. All right, so we have all that. Okay, so if I want to find sine of angle A, here's my angle A, right? Which one would be opposite? What's opposite A? No? The length BC, which is 9, right? It's little a. So that's going to be the opposite. The 15 is clearly the hypotenuse. So that means that 12 is the one that's adjacent. Do you guys see how it's next to it, but it's not the hypotenuse one? That's what adjacent means. So if I talk about sine of angle A, what is sine of angle A? What fraction? Opposite over hypotenuse, right? I'll write it out, which is 9 over 15. We can reduce it, so it would be 3/5. How about cosine of angle A? Try writing Sohcahtoa on your paper, see if you can spell it out. Sohcahtoa. So cosine is adjacent over hypotenuse. What's it end up being?
4/5.
Yeah, because it's 12 over 15 divided by 3, we get 4/5, right? And then tangent of angle A equals opposite over adjacent, which is 9 over 12. So divide by 3, we get 3 over 4. There's actually a kind of cool relationship between sine and cosine. You guys have this on your homework, but it's basically like, what if I asked you for, let's say, cosine of b? So what if I started with b instead? Well, now the opposite is 12, and the adjacent is the 9, right? Does that make sense? What's the sine of angle b and then the cosine of angle b? So sine of angle b would be opposite, which is 12 over 15, which was this one, 4/5, right? So the sine of b ends up being 4/5. What about the cosine of angle b? Guys, look up there. What's cosine of angle b? Adjacent over hypotenuse, and its adjacent would be, yeah, it'd be 9, exactly. So it's going to be 9 over 15, which is 3/5. So what's the relationship between sine of A and cosine of B?
They're the same.
They're the same, right? So basically, if you guys have, and we talk about this in Trig, and a lot of my students in pre-calc are like, wait, what just happened? Like, imagine you have like 50 degrees and 40 degrees. If I call these sides A, B, and C, and I ask you for sine of 50, it would be opposite A over hypotenuse. But if I ask you for cosine of 40, what's cosine of 40? Adjacent, which is A over hypotenuse. They're both A over C. So do you guys see that sine and cosine are actually equal to each other? When what? What about those angles? When those angles are 40 and 50, what's the word we use for those angles? What if I had 20 and 70, 25 and 65? Complementary, right? Those, if you have complementary angles, their sine and cosine values end up being the same. That's what co means, cosine. All right, anyway, that's a tangent. All right. Oh, I didn't even mean for that joke. Oh, that was terrible. Okay, so will sine and cosine ever be greater than 1? Why or why not? Will tangent ever be greater than 1? I don't know. Do you think sine can ever be more than 1? The sine of an angle? No. Why? Exactly. Do you guys get it? It can never be bigger than 1. Sine and cosine are always smaller than 1 because the hypotenuse is always the denominator, right? She said the opposite side, or the adjacent side, if you're talking about cosine, will never be bigger than the hypotenuse, right? So, no, because the opposite and adjacent sides are never bigger than the hypotenuse. So what about tangent? Can tangent be more than 1? Yes. So tangent of theta can be bigger than 1. Because opposite over adjacent could be greater than 1 if opposite is bigger than adjacent. Can tangent equal? Can tangent equal 1 ever? What would it have to be if tangent was going to equal 1? Koki, do you know?
What?
Can tangent equal 1? Tangent of an angle ever equal 1?
Yes.
Jacob's coming in for the save.
40.
He's saying 45. What are you saying? Can it ever be equal to 1? Yeah, if what? If you have an isosceles right triangle. These are all right triangles, right? So he's saying if we have an isosceles right triangle and opposite and adjacent are the same, then we're good. So Koki said, well, yeah, if it's 45 degrees, right? That's an isosceles right triangle. Then yeah, tangent could equal 1. You guys are using your noggins. I love it. All right, angle of elevation. Angle of elevation is if you have your horizontal line and you're looking upwards, that's the angle of elevation. Angle of depression, a lot of times it's like if you're standing on top of something and you're looking down. This is terrible, I know. I get the joke. I'm not making the joke. This is your angle of depression. All right, angle of elevation. Basically, if I have my eye line, so if I'm standing, and we'll do this with like, we'll go out and measure trees if it's ever like not snowing. I mean, it is, what, March 26th today? It's got snow on the ground. But your angle of elevation, if you're looking up, do you guys see this horizontal line where it's like my line of sight? So like looking straight out, the angle of elevation would be going up from my eye line. Okay? So the way I've drawn the angle of elevation is like I'm laying on the ground and looking up on the first drawing. All right, so it says the angle of elevation from the base to the top of a playground slide is 55 degrees. So we have our slide. And our angle of elevation is 55 degrees. The slide takes up 10 feet of space horizontally along the ground. So this is 10 feet here. Estimate the height and the length of the slide. Now I'm using H and L, but don't be confused. Don't think H is hypotenuse, right? So height and length. Okay, so let's say I want to find, I don't know, height first. Okay, identify what you have and what you need. Okay, we have 55 degrees, and this thing that's next to it is what we would call the adjacent side, right? Does that make sense? I want the opposite. Can I set up an equation using what I have, the adjacent, and what I need, the opposite? Can we do that? What would you use? Write out your word. Sohcahtoa. So we want opposite and adjacent. Which one do we use? Tangent, right? So we have tangent of 55 equals opposite, which is h, over adjacent, which is 10. And then we solve it out. So a lot of times I recommend to my students to think of it as over 1. Then you're able to cross multiply, right? So you're going to get the 10 and the tangent of 55 on one side. So we're going to have 10 tangent of 55 equals h. So in our calculator, we just do 10 tangent of 55. So we get 14.281. If I don't say, do 3 decimals. So that would be in feet. Okay, that's the height. How do I get the length? I could really do pretty much anything because I have that other number now, but what if we messed up? Have you guys ever done that where you like miss one thing on the test and then you like use that number for everything that's after it and you're like, oh crap, I've just missed every single one. I don't know if you've ever had that experience. I have, where it's like part A through L. You're like, oh my gosh. All right, we don't want to do that. So if we messed up this height, we don't want to use that. So I instead want to use what I was given originally, this 10, and I want to use L. Okay? So let's do it. So that's going to be adjacent and hypotenuse. So what do I want? Cosine. So I'm going to do cosine of 55 equals adjacent, which is 10, over hypotenuse, which is L. Okay, these are the ones students have trouble with. Try to find this answer on your calculator. So trust me, try to find it. Mackie, get your calculator out. Try it. All right, think about if your answer makes sense. Some of you, I'm guessing, have 5.73 something. Did some of you guys get that? All right, you did it incorrectly. Look at our picture. That's the hypotenuse. How's it going to be smaller than 10? Right? So here's what I want you to do. I want you to cross multiply. So it's like you're multiplying the L over. So you're going to have L times cosine of 55 equals 10. How do we get L by itself? we have to divide the 10 by cosine of 55, exactly. So we should get L equals 17.434. Does that make more sense? Yeah, so don't make that mistake on your homework. So think about, oh wait, that has to be the biggest one. It's the hypotenuse, right? Think about those things. All right, try this one. So draw it out. I'm going to give you guys a chance to try it. I'm going to go ahead and do this. All right, so you're measuring the height of a tower. You stand 154 feet from the base of the tower, and you look upwards. So this angle of elevation ends up being 38 degrees. So I'm 154 from the tower, or building, or whatever. Make it like a princess tower if you want. Mackie, you're going to love this chapter. She likes to draw little pictures all over her stuff. She drew some very cute fish on the last one. All right, so we have our tower. Like this. And we're going to try to figure out the height of the tower. So we want this height. You can call it X, Y, whatever you want. Okay, so we have 38 degrees. We want to use adjacent, and we want to use opposite, right? So if we have our word Sohcahtoa, and we want adjacent and opposite, which one do we want? Tangent. So we're going to do tangent of our angle, 38 degrees, equals opposite, which is h, over the adjacent, which is 38. Why did I do 38? Jeez, not 38. 154. I'm losing it. All right, so we're going to multiply the 154 over times tangent of 38. And we get h equals 120.318 feet. All right, so that's how tall it is. All right, does this make sense? All right, so the last thing we have to talk about is how do we solve for an angle? Okay, so sometimes you might hear me say, solve the right triangle. And what this means is you need to find all the missing angles and all the missing sides. So sometimes you might be given some sides and you need to go backwards and find the angle. Okay, so look on your calculator. Do you guys see how above sine, it says sine to the negative 1? Okay, that doesn't mean like in algebra 1 when you guys talked about x to the negative 1, it means 1 over x. That's not the same notation. That's not what we're doing here. So we're not thinking that. It's talking about inverse functions. So an inverse function, like if I give you multiplication, what's its inverse function? What does it? Exactly, it's division, right? So if I have square root, it's going to be square. Cube root, cube, right? These are opposite operations. So the opposite operation of sine is inverse sine, or sine to the negative 1 is how we read it, okay? Well, we read it as inverse sine, but you see it as sine to the negative 1. So if I want to solve for a, I have to get rid of this sign. Well, we don't divide sine. Like, we have to say a is equal to inverse sine, or you might hear it called arc sine is what we sometimes call it. It's going to look like that. So if I want to solve for angle A, I would have to do inverse cosine of y. And if I want to solve for angle A, I'd have to do inverse tangent of z. So what this means is sine of some angle, right? Our sine of our angle equals 0.9205. If I want to get that angle by itself, I have to do the opposite operation of sine, inverse sine of 0.9205. And they're not always nice. I think on your homework I made most of them nice. Or on this, not homework, on this notes. So see how it came out to be like A equals 67.0 degrees. They're not always that nice. I don't think the next one's very nice. Okay, so what is that? The measure of an angle, right? If you want to put measure of angle, that's technically the correct way of writing that. I'm not too picky. If you use a capital A, I pretty much know that that's an angle. If you use a lowercase a, it's going to be a side, right? All right, so if I do cosine of angle B equals 0.13, I'm going to say B equals inverse cosine of 0.13. Do you guys see how to do the inverse button on your calculator? So we do second and we hit the cosine button. Are you guys trying along with me? Try it along with me. Make sure you know how to do it. Yeah, like 82.5 degrees, right? We went to nearest tenth. Make sense? Did everybody get it? Do you guys see how we hit the second button and then we hit cosine and it gives us inverse cosine? So inverse tangent, well, we're going to do our inverse tangent button. So I'm going to do second, and I'm going to hit the tangent button. I'm going to do 11.425. So I get angle C is 85.0. And then I try this one and I do A equals inverse cosine of 1.620. So try it along with me. I'm racing you guys. Did you beat me? What does it say? It says error. What does that mean? Yeah, we talked about this. Remember, sine and cosine can't have values that are greater than 1. So cosine is never greater than 1. I know I haven't spelled out sine and cosine. Sine has an E on it. We just abbreviate it S-I-N, sin, but we say sine. So why did 4 have an error? Because we can't have sine or cosine being greater than 1. All right, does this make sense? So if I'm trying to solve for an angle, so let me skip to like number 7. Let's say I want to get angle R. If I want to get angle R, I have the opposite and I have the hypotenuse. So if I'm trying to find angle R, I need sine, right? So you can write your Sohcahtoa up there if you need to. Colin, you were supposed to put it over there. So we have sine of angle R equals opposite over hypotenuse, like that. So angle R is going to be inverse sine of whatever 7 over 10 is. So we do that on our calculator. So we do inverse sine. So second sine, 7 over 10. And we get 44.427 degrees. That's our angle. If I use the word and I solve, and I say solve the right triangles, what that means is I want my 3 angles. And I want my 3 sides. I gotta find all that information. All right, we already had some of it. We had at the very beginning of the problem that angle K was 90, clearly, right? Little r, where's little r? What's little r? That's the one that's across from angle R. That's 7. And little k is the one that's across from angle K. That's going to be 10. So we already had 3 things. You'll always have 3 things at least. And we got that first angle was 44.427 degrees. All right, Ian, how about this question? All right, we have 2 angles in that triangle. What's the easiest way? Like, think back to semester 1. What's the easiest way to find angle G? Yeah. So if I do 180 minus the sum of those, right, I get 45.573. You know what I typically do? I know if I already have 90 that these two make 90 as well. They end up being complementary. Does that make sense? So I just do 90 minus my answer from before, my answer R. All right, what if I want to get little g? Little g's over here. What's a way not even using trig? How can I find little g right now? A squared plus b squared equals c squared. Could I find it another way? Sure, I could set up sine, cosine, tangent, whatever I want to do, right? But let's say I want to find that. I would say 7 squared plus g squared equals 10 squared. Just make sure you put the hypotenuse in the correct spot. So I do 10 squared minus 7 squared, which ends up being 51. So g ends up being the square root of 51. So you can write it like that, or if I say round to 3 decimal places. Oops, I did not do that. Right? Calculator. 7.141 is what you would get. Does this make sense, how you can find all those missing sides? So we're going to continue to practice this tomorrow, but I want you to do your homework and try your best. And we can answer some questions tomorrow. Let me stop this.